It seems like technology can make everything better. Well, it turns out there is a serious problem with the loss of water in the world. How can we turn that around? Well, it turns out there's a company focused on that, and they have found a solution that will inspire you as much as it inspired them. It is an incredible fix. It is what we're talking about on this episode of Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio. I'm here with Fridis and I'm here with Kevin. They're both from Powel in Norway, all the way across the ocean, to talk about their solution we call SmartWater. Kevin, thanks for being on the show today.
Thank you.
Now, you're the CTO of Powel. Tell us a little bit about who Kevin is.
Okay, well, I'm actually an American. I'm from Seattle. Grew up there and worked actually at Microsoft in Redmond for over 20 years. The last group was in the developer division, working on things like .NET and WPF actually. We bought a company in Oslo that I came over to work on, and then decided to stay. And so I joined Powel back in October, and I've been here for almost 8 or 9 months.
Very nice. What do you think of Norway?
I love Norway. It's great natural surroundings, and it's a nice place to live.
Yeah. It's what a beautiful country. Now, Fridis, you have been in Norway for a long time.
Yes, I'm Norwegian. I grew up in a small village, I would say, in the mountains called Røros. I'm a water engineer. Have background from research and consulting. I joined Powel about 2 years ago, and I'm working with software development for the water and wastewater sector, basically, water services.
Very nice. All right, so Fridis, you're a water engineer. That fits pretty nicely with Powel. Tell us just for a second about what a water engineer would do for, what's a water engineer?
Yeah, actually, it's the education is civil engineering. So I'm dealing with everything from water, from the water source, giving a good quality of the water, getting the water in pipes to the people, and then taking care of the water after you have used it.
Okay.
It includes the sewer system and also the receiving waters. That's basically the whole services that we are taking care of, and then I've been doing different things in that area. Water treatment processes, rehabilitation plans for pipes, benchmarking systems, flood protection, and all kinds of things.
Everything you could dream up with water.
Yeah, well, actually, it's everything that are linked to the public services of water.
I see. Okay, so Kevin, you've got a water engineer and all kinds of things going on there with Powel. But some people may not know who Powel is. We know you're a large company, but kind of walk us through who Powel is and why a water engineer would work for Powel.
Yeah, so it's a large company in the sort of industry that Powel operates. Powel's about 20 years old, and it's been providing software solutions and applications to the energy and utility industries for that entire time, and just growing the portfolio. It has a very broad, unique portfolio of solutions for water and infrastructure and energy. For energy trading, grid management, and some renewals tech, and some things around microgrids and so on. So it's a bit unique in that respect. And as you can imagine, it's been a traditional ISV in the sense of it's had delivered applications and servers on premises at utilities and the municipalities for most of this time. But has recently, in the last 4 years or so, been transitioning to a modern cloud-oriented application model. and business model
Okay.
as well.
So
But
it sounds like there's two big parts of Powell, one that has to do with power and one that has to do with water.
no, we have actually 5 different business units.
Okay.
We have construction, civil construction for roads and bridges and tunnels and things like that. But we have water.
Yeah.
We have what can be called the grid infrastructure management, and then something we call smart energy, which is focused on energy trading and inflows of water and water generation and things like that. And then the final is metering, smart metering.
Okay. Powell likes smart things and likes smart water, this project that we're about to talk about. A lot of smarts in Powell.
Increasingly smart and digitized, yes. Mm.
And digitized. All right, well, tell us just a little bit about the SmartWater project. Actually, let's just step back again. I know that the SmartWater project is going to solve a problem. Start introducing us just a little bit to what the problem is with water distribution.
Yes, I would love to. The problem that we are going to solve here is water leakage problems. Actually, in Norway, we have lots of water. Today and this week, it's more or less constantly raining. So we have really a lot of water, but still, in the water distribution system, we lose approximately, in average, 30% of the water.
Wow.
Yeah, so that is in Norway. Some companies have bigger losses, some are more clever. And there are several...
Now, where does the water, how do you lose water?
Mainly in the pipes. All the pipes are underground. You can't really see what's going on there. A lot of the infrastructure is really old. The pipe has a lifetime of about 100 years economically. So that means that they try to keep them as long as possible. And then it's hard to detect when and where there's a leakage. It could be anywhere in the system. Really big ones, they surface. Then you get a big hole in the ground or in the street, and the water...
Those are the easy ones to find.
Yes, those are the easy ones, but you have a lot of small ones that is hard to detect and discover. So these are the issue that we want to solve with this SmartWater project.
I can't even imagine how you could solve this problem. With all these pipes are underground, all these pipes go for miles and kilometers forever. How do you detect a leak that's not so big it makes a change in the earth?
They have systems to already a lot of data and systems that can take care of some of the problems, but what we were thinking was to help the utilities to understand and analyze their data by using machine learning. So put them together so that they understand when and where possible leakage is happening. So we have, from what we have done so far, only done a small percentage of the whole idea, but we started then to try to discover when the leakage occurs.
Let's talk about how we sense it. And I'm trying to wrap my brain around it just a little bit so I can understand how you would detect something that seems so difficult. I guess at the beginning, I put in a certain amount of water, and at the end, I realize there's not quite as much in there. So I know there's somewhere in this gigantic, pipe, there's a loss. And then what's the strategy to start to identify which part of the pipe is leaking? Do I need to have a series of sensors every certain distance, and then I start figuring out it's in between that? And what am I measuring? Water flow?
It's water flow. That's correct. Actually, the pipe network is divided into zones. They don't have a lot of meters, but they have 1 meter or several meters per zone, measuring every water going in and out of the zone. So they have the sum. They know how much they have in the zone. and they normally have what we call a SCADA system to monitor this. So what we have basically done is actually quite simple. We just took that data, a lot of the data, historic data with up to 10 seconds for 3 to 5 years. We put them all into a machine learning model and train the model to understand the expected pattern during a normal day, normal week, time of month. So this model then predict what's
also
normal.
factoring in things like weather, so that you kind of get a profile for how water should be flowing through the system at what volumes, given the season, the weather, the day of the week, the time of the day. These are features that factor into the model.
So time of day and calendar, those are things I can kind of predict and maybe see a pattern, but weather, then you throw that in as a variable that once you know the weather, you might know its impact, but you can't predict what the weather would be on that calendar day, whatever it's going to be. What are the things that impact and the flow of water? Why would weather even make a difference, Kevin?
Well, people use more water when it's hot, for example. Simple example. So weather patterns, usage patterns do vary according to the weather. And so you don't necessarily need to predict what the weather is going to be tomorrow. It's more about what the weather is doing right now, so we can get real-time understanding of what the consumption should be or what the flow should be at any point in time.
Okay, so now I have the gist of that. I know what water's coming in. I have a prediction of how much usage should be inside that zone, and now I see what am I measuring now? How much is coming out on the other side, and seeing whether or not the usage matches on what's actually coming out, and then maybe there's a loss of too much water being used, and that's an indicator of a problem?
Yeah, actually we're measuring all the consumption in one zone, one area.
Okay.
So we make the prediction as a guideline, you might say, and then on top of that, we add online data. So measuring every minute or second or whatever measurement that you might have, and then we compare this with the prediction. And when the measured data exceeds the expected level for a certain period of time or for a certain amount of water, then we expect this to be a leakage, and the system will then give a warning to the operator. Yeah.
And it's important to note that it's indicating an alert. It doesn't mean there's necessarily a leakage. So Powell has the other aspects of the water system, like the infrastructure, the service reports, citizen reports, things of that sort. Maybe there's been a fire and they're using the hydrant or something. So we get this 360-degree view on what's happening with the water system to know whether a specific alert or indicating an anomaly is actually something that we need to dispatch a field crew to investigate. And we can do this kind of real time. And as we get more sensors, more and more localized, so that we can get on top of the leaks quickly.
And the reason you want more sensors inside is so that you can start narrowing down where the problem is. How do you, like today, I don't know how big a zone really is, but what's the size of a zone, Kevin?
I think I'll leave that to Freude, so she's the expert on that.
Oh, yeah, Freude.
Could be any size, actually. From our test cases, we have had zones from about 2,000 inhabitants up to about 20. So this all depends on the utility or the water company. Some companies have been, should I say, more clever, dividing their system into smaller units, and it's more easier to analyze it and to understand the situation. Others have bigger ones, and then even they need this system even more, I would guess.
Now, Frodis, tell me just a little bit about the scanner or the device itself. So we have a sensor. It is it's able to measure water flow, but then I'm able to communicate. How do I talk to it? What's the communication mechanism with these devices?
Yeah, actually the data that we used to train the model and also the online sensors, they are state-of-the-art sensors that have been in the system for could have been 20 years or so. So they are nothing high-tech at all, actually, but we are planning to add more sensors because now there's a variety of small sensors that are getting cheaper, and that it's also a lot easier to send the communication to in the cloud and to use it in our system. So we are now planning to add more sensors into the system, and then it's pressure sensors first of all that we are interested in.
Well, and that's a good point. This is not a new industry, right? Water's been around for a long time, and these sorts of sensors, we didn't just dream them up. People have been thinking about measuring this sort of metering this sort of water for a long time. And so when you dream up a solution that's going to be clever and bring extra value, you can't say, let's take all the existing sensors and rip them out and let's put in brand new ones that are going to do exactly what we want. Somehow you've got to make it work with what's already there. Sounds like that's exactly what you've done.
Yeah, actually we're only using data that they already have. It's just that we are using them, analyzing them, and giving them back in a way that they are more useful for our clients.
Yeah, and to that point, as municipalities modernize and smart city initiatives and so on, they will have more modern sensors come online, and this solution just gets more interesting in that scenario.
Right. So one of the ideas, of course, is to increase data because that'll help you narrow things down. But also, how important is the speed of data from these sensors so that you can react to problems that you detect?
Honestly, not that important. It's good. It's good to have frequent data, but when something happens, it's not like happening.
It's not like a gas leak,
in
a
a
water
second
leak's not
or
like
in a minute. You would have time to discover. So
if it's
some minutes.
If it's a really big leak, as Frodis was saying earlier, then it's going to surface in some way. What we're trying to find is the 1,000 small leaks that are causing so much water loss. In a scenario where water becomes an increasingly scarce resource, having 1,000 pipes in a municipality slowly leaking water undetected for a long period of time is a problem. So it's not a question of super urgency, but it's a question of discovering them and getting them fixed.
I see. So this really isn't about solving the gigantic problems. It's solving the compound problems of all the little ones that are bigger than the gigantic problems if you really look at it. 30% water loss seems pretty significant to me. If I lived in, our producer, Chris, he lives in Las Vegas. If I lived in Las Vegas where water is unbelievably scarce, 30% loss, that's tragic.
Yeah, absolutely.
Yeah.
Absolutely.
And if your systems are able to predict where some of these losses are, I'm able to recover, let's just say 10%, and now I'm only losing 20% instead of 30%. That is an incredible value, and I didn't have to go find more water. I'm basically just not throwing away so much water at the same time.
Yeah.
That's right.
So the opportunity is in older cities mostly, or what do you see the opportunity here for systems like this that monitor water distribution flow?
I think any city would have use of this kind of system. It's not just only the water alert or the machine learning bit that we did of it, but it's, as Kevin said, the holistic view of how we utilize this data and help the operators or the managers of the company to understand and act when something is happening, and quickly. That is important.
And also just planning better. As Curtis was saying, these pipes are buried underground. It's very disruptive to replace them. You have to dig up things and so on. So
Right.
understanding what's happening with the infrastructure and knowing which pipes are likely to fail in the very near future in a kind of a predictive maintenance scenario is also something that we're looking into.
Yes.
Yeah. Boy, ML and predictive maintenance go hand in hand, don't they? To be able to see what's there and what isn't there. Fridis, how long does it take for you to be able to establish a baseline? If you come into, my city and everything, are you relying on historical data, or can you establish a baseline?
The baseline, I would say, if we get hold of the data, we can do it in a day or so. For one, but it also depends on how complex and how big the city is. If it's divided into, let's say, 100 zones, then we would have to spend more days. But we are currently working on testing this system on several municipalities in Norway. So one of the things we want to gain more knowledge about is how much training we need for each model. Probably we don't have to do training for all the zones in one city. If there are only residential areas, for instance, then we can use like a residential model for them, and then we can use like a downtown area would have a different pattern, or an industrial area would have a different pattern. Then it would be quick, but we need to gain more knowledge about it.
There's a big caveat there, and Freudis touched on it a little bit, which is I think we all know that data, the quality of the data matters a lot. So if the municipality has poor quality data, then we're going to spend a lot more time massaging that data into something useful. And they say that the average is 80% of the time of a project is spent on that data cleanup, and I think the experience at Powell is that's pretty accurate.
Yeah. Well, that's just the real world, isn't it? That people think they are getting great data only to not be getting great data. And so now you have to do all these gymnastics. But that's part of the value add. That's people like Powell or companies like Powell come in, and they're able to do these things that almost feel like magic whenever you come up behind them. All right, so I'm at my city. Thank goodness Powell has finally come in. I have a couple of sensors. You guys have added a bunch of sensors. You've established a baseline. You're using all these models that you've proven in other cities and other places throughout time, and now I'm starting to see these changes. I've saved some water loss. I've been able to identify some places that should not be using as much water as they are, and you're becoming more and more effective because I'm giving you more information about my city. I'm saying things like, here's what the fire department is using, and here is, and just fill in the blanks, all the other information that gives you this bigger vision so that you can add all these other variables to say, hey, there's all this loss. That's okay. That's because they turned on all the, the fire extinguisher, not fire extinguisher. What's the word I'm looking for? Fire hydrants, right? Yeah. Okay, so now I've got the gist of it. Now, have you started showing customers? What are customers saying? What's the reaction that you're seeing when they see this type of system?
Yeah, we get actually a lot of positive feedback and a lot of interest, not only in Norway, but also abroad. So we have to figure out how to handle this so that we can scale up quickly. We are really eager to get going on this project and to spread it out, actually.
Yeah, well, I just want to add to that. As I was mentioning, that a lot more of Powell's business is global, and we are building scalable SaaS type solutions. That's what this water alert thing is designed to be. So while we're testing the solution out with municipalities in Norway, the plan is to very nearly bring that in a very short time bring that to the international market.
Nice. Now, during this project while we were putting it together, so this is really an IoT project, right? I mean, when you look at it and just step back, you're like, how are you doing all this? Well, it's a standard sort of IoT implementation. As you were going through it, did you have any aha moments? Anything where you were like, wow, something just happened that was really, really great?
Well, I think you have to give credit a little bit to the Microsoft subsidiary here. We are a partner with Microsoft, and we were engaged in the Ascend program. So a couple of folks from Microsoft, including Pedro Diaz and Ulf Tollefsen, came and did a workshop with Powell, an intensive 2-week workshop where we got together in a room and we brainstormed around some interesting ideas, and really thinking about the business value and the customer scenarios and how IoT could factor into that and how machine learning could factor into that.
Yeah.
And we came up with this scenario, and the team built this, the entire first POC within that time frame, also while doing the DevOps portion aspect. So, big credit to the Microsoft folks there who were working with the team to make that happen. So the origin of this thing is of this particular aspect of the water solution is really there.
During that kind of workshop that they had with you, well. And isn't it amazing what 2 weeks can do? Just to dedicate a little bit of time, and all of a sudden, you've got a new
clear
product.
away the noise and focus. Yeah.
Yeah, it's really great.
Actually, we did a little bit of preparation, and then we were working a bit on data before we decided to meet again. And then everybody just went to one place, worked together for a whole week. Really long days, but really inspiring, and it's amazing what you can do when you really focus on something. And also we worked very much on the DevOps part of it, and I think that was maybe one of the...
Talk to me a little bit about the DevOps side for it. What is that? What do you mean?
Well, as I mentioned, that Powell's been going through digital transformation, and part of that is really looking at the way we develop and deploy our software and solutions to customers. And the desire was to optimize the value delivery pieces, and it was so DevOps was a key piece of just sort of examining that and seeing if we couldn't make it a lot better. And the funny thing, or the interesting thing, is when you get everybody in a room and you have everybody describe the current way we do things, and seeing the different views on it, and understanding that no one person had the complete view. So then working through that, I think we moved from a 12-week deployment down to like a 3.5-week deployment from the inception of the sort of the thinking of a new feature to actually deployed to a customer. So I think
that's a third of the time. That's impressive.
Yeah, that was an exciting thing for the team, and then we used this framework through the workshop. Through those 2 weeks. So there was some learning that had to take place there. People had to get familiar with the tools and so on, and a slightly different way of doing things while we're doing this new IoT and machine learning thing as well. So it was a intensive, useful couple of weeks.
Yeah, a lot of learning all at once. Isn't it amazing how when everybody sits down to talk about process, there's so much to improve. You could almost turn around the next day, let's sit down and talk about process, and there's more to improve. It seems like there's always something. It's kind of like, to me, it's kind of like cleaning a boat. Every time you get down, you're like, there's a barnacle, and you clean it off. The next morning, you're like, well, let's see there's another barnacle. It just kind of, things just grow on process, and it just slowly gets bigger, and you always need to kind of tend it like a gardener sometimes.
Exactly, yeah, that's true.
Yeah.
But
so now it's a brand new Powel.
Yeah. But also this hackathon, I think it was like really inspiring for all of us, both from Powell and Microsoft. My impression was because we could really see the benefit of the different way of working immediately. We saw the model building while we were there, literally.
Process, especially difficult process, is such a barrier to great ideas, right? And so being able to execute something, you're like, hey, I've got a great idea, and it'll take a year to do, right? And it's like, forget it, that's too much, right? It's neat when you can enable things to be, even at, fast doesn't mean this afternoon. Fast can still mean a reasonable amount of time, just not a burdensome amount of time. That's pretty great. So it's a two-part process for Powell. For one, we start looking at the IoT side of things, introducing models, introducing all these pieces around, I'm sure, stream analytics. And then at the same time, we're all going to work together in a new, very tuned process, and we can see how well it works. Sounds like the process actually worked as well. Are you guys taking the process improvements that you did during this workshop and then implementing it inside your own development teams now?
Well, there are many development teams at Powell, and so some are further along in the DevOps continuum than others. And so it's as I mentioned, Powell's going through this digital transformation, and it's a process, but it's one that's steadily improving. So
now, not Powell, but Jerry Company over here. We're about the same size as you, totally different industry. We're thinking about DevOps. This is pretty interesting. What would be a word of advice from one CTO to another that you might give to me as I'm considering this DevOps process?
Yeah, I think it's not just a sort of a gimmick or just a trend. It's something that actually optimizes the way you can deliver value and allows you to deliver continual value and get data back for your efforts. So I think it's a worthwhile investment. And at least my approach is to start with the first team and then socialize the improvements across the company that way. So Water was, some other teams were using DevOps-y things, but Water was the first through the entire sort of evaluation process.
Okay, got it. So start small, prove it, and then make it contagious because it's so effective.
Exactly.
Okay. That makes sense to me. Now, Freydis, tell me just a little bit about what's next. So we're looking at this project, and you've done some neat things. What's an aspect of this SmartWater solution that you hope to really dive into next?
Yes, as I said, we basically produce this baseline, as you say, with the existing data from the existing systems. But we are really eager to test new sensors and sensors that are easy to just include in the system with communication. And the first that we're going to test is pressure sensors. And our plan is to use them to help localize the leakage, not only saying, hey, here it's too much water, but now we also want to help the utility to go more accurate. We have also other systems as we use that we use as support to localize, but we also think that we could be even more accurate with more sensors, and we are eager to test how many sensors we need. Maybe 2, 3, 10, depends on the size. So
right. Yeah, because more sensors you have, the more accurate you are, but then there's some threshold where you have too many sensors. You don't need that for that level of accuracy.
Yes, and actually we have another interesting thing is we are looking into other topics as well in the water sector, both for water and wastewater systems. So we have also plans to do similar things on the wastewater side.
Okay.
And this summer we have summer interns, students in Powell, 26 students, and they are spread throughout the 5 different departments, and they have the opportunity to look into innovation projects in the water sector or in the other sectors that we're working with. So we are quite eager to see what they will dive into.
Nice.
Yeah.
Now, Kevin, you kind of sit back and look at all 5 sections, not just water, of Powell. And here we are inside just water for now, talking about IoT Stream Analytics, Power BI, all of these things, making a pretty fast solution. What do you see next? Like, is there another area that you're like, I think they're a pretty good candidate for a similar type of solution, and take the learnings from one over to another?
Actually, it's a really good question. We have at Powell a common data science team with a set of smart data scientists and a chief data scientist and things like that. And and we're building a common data platform which can serve the different product units. And we also have, an endless list of opportunities and scenarios, cases, if you will, that we're putting in a prioritization framework. So every business unit has a pretty long list of prioritized use cases and machine learning scenarios that we are working through. So the water case is one of them, and we also have some wind power things without going into too much detail. We have quite a number of things. So it's this IoT type machine learning type solution is something that Powell is going to be doing or is doing a lot of across the different business units.
It's funny, these types of very straightforward solutions, they're almost like poison ivy. I don't know if you have poison ivy in Norway or not. We don't have it in Colorado, but I grew up in Missouri where it's everywhere. It's so contagious, and these sorts of things are so contagious. One team gets it, and everybody else suddenly starts scratching about it. They're just like, wow, there's something really cool there. And it's neat to me, it's neat how once data is available, people start thinking in brand new ways, right? Before the data is available, the only way they're thinking is how do we make the data available? Once the data is available, once they can do these sorts of things without making them gigantic science projects in order to figure out, all of a sudden these new ideas come up, these new business models and business products and things that really were so distant that they weren't even worth dreaming about, suddenly they're on the table, and you can start talking about things in terms of, a year or two rather than, a decade or two to be able to get it in place. Sounds like Powell has really made a strategic investment, not just in this workshop, but it sounds like with you and, all the data science work you're doing, Powell's really, there's a lot of high-tech stuff going on behind the scenes making it possible for your company.
Yes, absolutely. It's an exciting time to be in this particular industry. I wouldn't have predicted 10 years ago that I would be working with utilities and energy, but the kind of transformation that's happening now is it's world-changing stuff, and it's important. So it's exciting to be part of it.
Yep,
I agree.
It is important. It is important. Friedrich, thank you for talking about this process and what you have discovered around your solution around water and SmartWater. Thanks for being on the show today.
Yeah, you're welcome. Thank you.
Kevin, it's been great talking to you too. Thanks for being on the show and talking to us about Powell.
It's great. Thank you so much.
You bet. We'll see you both again.